Welcome to myprojectbazaar.com. Let me discuss about the process video object tracking in compressed domain using spatial temporal Markov random fields. Let me discuss about the process video object tracking in compressed domain using spatial temporal Markov random fields. So in this process, initially the input videos is taken and it is pre-processed in order to remove the noises from them. So for pre-processing we are applying Gaussian filter. So the Gaussian filter smoothes the images and preserves the precious bits in the video. Then after that the objects in the videos were identified using the segmentation algorithms, which is based on the color-based segmentation algorithms such as k-means, and also we are obtaining the objects based on the background subtraction method, which is based on the frame differencing method. So we are subtracting the each frame from the empty background, and we are getting the foreground objects alone. Then after that the movements of the objects were estimated using the GME. So for that we are calculating the motion vectors in the process. The labeling dependence of the constitutive difference is calculated using the motion vectors. At the same time using the similarity of the context and the neighboring motion vectors within the frame, the labeling dependencies were also calculated. The motion vectors are assigned to the most probable places based on the identified objects in the video. Rectangular boxes drawn around each identified objects in the video. So this process goes on like this, and we track the moving object in the video. So this process will track a single object in the video, and also we are estimating the motion of the video. So it tracks from the first frame to the final frame the moving object in the video most accurately, but it tracks a single object only. So based on that we are proposing the scheme. So this object this is the process. Let me see the flow of the process. Video object tracking in compressed domain using spatio-temporal Markov random fields. So initially the input video is converted into frames and pre-processing is applied. For pre-processing we are using Gaussian filter. So Gaussian filter smoothes the video and make all the pixels in the images more clearer. In order to apply Gaussian filters, you use filter function. So the precious bits were restored in the input videos. Then we are estimating the movement using GME. The labeling dependence of the consecutive frames is calculated using the motion vectors. At the same time, using similarity of the context and the neighboring motion vectors within the frame, the labeling dependencies are calculated. These values are combined and with our motion vector is estimated. Instead of only using the motion vector, our proposed system uses additional dimensions by including temporal dependencies into the Then after that objects are detected based on the calculated motion vectors. So the objects in the videos are segmented using segmentation algorithms, and then using the background subtraction method which uses frame difference method. The Markov random fields are applied to detected objects in order to identify the spatial temporal features of the detected objects. Then we perform labelings. We are labeling referring to taking the measurements of the objects such as the centroid position, bounding box values, and the area like that. So after calculating that, we are moving to the tracking process. So based on the calculated height, width, and the area position of the detected objects, a rectangle is drawn around the moving objects in the video. So the height and width of the blobs becomes the height and width of the rectangle. The center position of the rectangle changes according to the centroid position of the blobs identified. So based on this we are tracking the objects, and we conclude the moving objects as the tracking the objects. So we are providing a screen which tracks a single object which tracks the single objects which is present in the video based on this process. So let me discuss about the execution of the process video object tracking in compressed domain using spatial temporal Markov random field. If you want to run the code, select the file main.m, which is located in the source code folder. Right click it and click on run file. You will get the guide window which is required in order to run the code. So first load the video by using the load video click button and select the video that is given by us. So the video will be displayed here, and it is converted into frames, and the video will be displayed here. Now the video is displayed here, and after that we are converting them into frames. So for frame conversion, the frame conversion result is displayed here. Then after that we are applying pre-processing. So each frame is pre-processed and the result is displayed here, and also these frames were saved. Then in object detection, we are detecting the objects based on the segmentation of the foreground objects by using the color segmentation method such as k-means, and also we are segmenting it using the background subtraction using frame differencing method. So this result is displayed here, and segmented objects were saved in the folder detected objects. So after the objects have been detected, we will move to the next process, which is the object movement identification. So this process is going on like this. So in this process, here the movements of the objects were identified and the results are displayed. Also the objects are detected by results, and then the motion of the objects are estimated based on this process. After the movements of the objects were estimated, then we move on to the tracking process. So we are tracking the moving object by plotting a rectangle over it. So the identified objects were tracked based on this process. Thus we are tracking the moving objects which is present in the video.